Right, so this is the first of two videos looking at the section on interpreting graphs. The focus of this video will be on reading graphs, and the next part will be on making graphs. And these terms, that we see here, we'll use to various amounts, and the two words extrapolate, interpolate, and interpolate kind of go together, and we'll work with these. But extrapolate is when you look at some sort of relationship and you extend the pattern beyond the data we have to make an assumption, to make a prediction. And interpolate is where you look within the data we have to make a prediction or an assumption. And we'll see this in a moment. And intercepts are points where a graph crosses either the horizontal or the vertical axis. In general, any two-dimensional graph will have a horizontal, which you call the x-axis, and a vertical axis. And wherever the relationship crosses that point, we call it an intercept. So we have quite often x-intercepts and y-intercepts. So, as always, the best way of understanding this is to look at an example. In this case, I have a relationship showing the connection between Celsius and Fahrenheit, two different units of measuring temperature. All right, and so you see this graph here with, on the x-axis we have degrees Celsius, on the y-axis we have degrees Fahrenheit. And you can see the relationship. You can see it's a linear relationship. It's forming a straight line, as well as I have two very specific points with the coordinates labeled. And so just by reading this point right here, this point, well, actually maybe first what I'll do is answer this first question. What is the y-intercept and what does it represent? Well, the y-intercept is this point right here. And more specifically the 32, because the 0 just tells me it's on the y-axis, but the y-intercept means where does it cross the y-axis. So it's a 32 that really matters. And so the y-intercept of this particular relationship is 32. And this represents what? Well, this represents the equivalent of 0 degrees Celsius in Fahrenheit. So again, the 0 is the x-coordinate, which is on the x-axis, so 0 degrees Celsius, and 32 is a y-coordinate, which is referring to the y-axis, so degrees Fahrenheit. So this represents what 0 degrees Celsius is in Fahrenheit. Now, what's special about 0 degrees Celsius? 0 degrees Celsius is the freezing point of water. So I'll say a few things. I'll say this represents 0 degrees Celsius in Fahrenheit. I'm going to try to spell Fahrenheit properly. But as well, more specifically, that's the freezing point of water. Oh, my writing's really messy there, but oh well. And so I'm just going to go up here and change this 32 to 32 Fahrenheit. Right, so 32 degrees Fahrenheit is when water freezes at sea level, equivalent to 0 degrees Celsius. All right, so that's the intercept. So an example of interpolating. Interpolate to determine the y-coordinate when the x-coordinate is 10. What does this point represent? So if I look at my graph here, I give you two very specific coordinates, 0, 32, and 20, 68. Well, when x is 10, right here, that's this point right here. And so what is the y value? I know the x-coordinate is 10. I know it's 10 comma something. Now I can estimate it by looking at the graph. I can see my y scale is clearly going up in 20s, 20, 40, 60, 80, 100. So it's roughly halfway between 40 and 60. I say roughly because is it really halfway between? I don't know yet. But I know it's roughly around 45 degrees. Okay, but let's be a little more specific or detailed. I can see if it's halfway between these 2 points, 0 and 20, it must be halfway between these 2 points, 32 and 68. This relationship is a line, so if I can find the halfway point between 32 and 68, I'll know exactly what that value is. Again, it looks like 45, but maybe 44, maybe 46, I don't know. And so how do I find halfway between 32 and 68? Well, if you want to find halfway between any two numbers, what always works is add them up and then divide by 2. So if I take that 32 plus 68 and divide by 2, that will tell me exactly what's halfway between these. So 32 and 68 is 100. 100 divided by 2 is 50. All right, so, oh yeah, To be honest, what I said before was pretty lousy estimation. Sorry, halfway between 40 and 60. Halfway between 40 and 50 is 45. I'm not sure how I got 45 there. But anyways, looking at this, yeah, it looked like it was halfway between 40 and 60. That's what I really should have said. And now I know it really is exactly halfway between 40 and 60. So the coordinates of this point are 10, 50, which means 10 degrees Celsius is 50 degrees Fahrenheit. So that's an example of interpolation. I looked within the data. It wasn't directly stated, but I could figure it out from looking at the data. So I'll say 10 degrees Fahrenheit is the same as 10 degrees Celsius. All right, and again, that 45 degrees that I was mentioning before would have been a good estimation if my Y scale was going up in 10s, but it was going up in 20s, and I said it was going up in 20s, but whatever. We all make mistakes. And so the last thing I want to look at is the boiling point of water is 100 degrees Celsius. Use this to extrapolate the boiling point of water in Fahrenheit. So if I look at this graph, I know that 100 degrees Celsius is the boiling point of water, but 100 degrees Celsius is off my graph. So I need to kind of continue the pattern beyond what I have, and that's an example of extrapolation. And so first, just visually, 20, 40, 60, so 80 is about here. I'd say 100's about here roughly. Continue this. This is hardly that accurate, but it's a good estimation. And so looking this way, what's that about? Well, 100, 120, 40, 60, 80, 220-ish, something like that. So I know it's roughly, I want to get better than this, but I know it's roughly 210, 220, a little over 200 degrees Fahrenheit. All right, but that's a pretty good estimation, but let's be more accurate than that. So how can I extrapolate a little more with a little more detail? Well, I can see what I have here is a line. And so I can also realize if I go from 0 to 20 degrees, I went from 38 up to 62, which is a difference of 36. So when I went up 20 degrees in Celsius, I went up 36 degrees in Fahrenheit. So that means I know if I do that again right here, I must go up 36 degrees. And so if I go 36 plus 68, I know this must be about 104. And I can do this a few more times. Or I could try to speed it up by multiplying at some point, but I'll just keep doing this. So I'll go up by 36 again. So add another 36, and I'm at 140 degrees. Go up 36 again. And so I'm at 176 degrees, which relates to 80 degrees Celsius. And so one more jump. And so if I add another 36, that brings me to 212 degrees. And so now I'm still extrapolating, but it's much more accurate or detailed than what I did before. And keep in mind, I easily could have sped this up a bit if I wished. Once I realized this first jump was 36, I could have realized, OK, to get all the way to 100, I'd have to do an extra 1, 2, 3, 4 steps after that. So I could add 36 times 4 to 68. Lots of approaches. Once we know something has a linear relationship, once it keeps going up by a constant amount, then we can continue that rather easily. But in the end, it should come to 212. So that's an example of extrapolation. So I'll say 100 degrees Celsius equals 212 degrees Fahrenheit. And so lastly, that extrapolation I did there is very accurate because the relationship, I know the relationship between Fahrenheit and Celsius continues in a linear manner. But if we don't know that for sure, then the farther we move off the data we have, the less confident we can feel about our prediction when we're extrapolating. Depends on what the relationship is. But with that said, that finishes this part focused on reading graphs. The next lesson will be focused on making graphs.